Hello, everyone, and welcome to another podcast broadcast of This Week in Science. Oh, apparently, once again, we are having trouble broadcasting to Facebook. I don't know what's going on there. Start, go, do, save, make, happen. Facebook? No, of course not. But anyway, we're on YouTube and Twitch right now. If you have friends who would be watching on Facebook, tell them they should head on over to YouTube or Twitch. This is what we do every week, Wednesdays, 8 p.m. Pacific time. This Week in Science talks about science, things that we like to talk about, things that you want to hear about, things that we all want to connect over and make our brains go, what? Hit that like button, share button, boop-bitty boop boop algorithm fun button, and I don't know, this is what we do, and some of it will be edited for the podcast version, of course. So are we ready to go, Justin?
Absolutely.
150%. Did I cut my head off again? I did. I think so. Anyway.
It's got like the extra zoom on the one shot. I don't know.
I know. I'm not ready for it. Oh, and just as the show was getting started, I was telling Justin that it appears there are spiders, little teeny tiny spiders everywhere, all over my studio. So just in case I suddenly go, but they're tiny, they're little babies, they're going to get bigger.
But not during the show.
Not during the show.
Nope. They should remain the same size.
I love nature. I love it. I love it. Okay, so let's start this show. Welcome, everyone. Thank you for joining us. Starting the show in 3, 2. This is TWIS. This Week in Science, episode number 940, recorded on Wednesday, August 23rd. When will science solve aging? I know this is something that we all want to know. I'm Dr. Kiki, and we're going to fill your head tonight with consciousness, doom, and a toilet. But first,
Disclaimer. Human culture. It's a somewhat unavoidable aspect of being human. For some cultures, the entirety of what being alive entails. For others, culture is just an accumulation of conditioned behaviors and responses, wrapped around a population branch like an opportunistic vine, taking root separately from the tall timber of humanity. Culture can be a beautiful, and culture can be an ugly thing. It can bring people together, and it can tear them apart. And when it comes to science, human culture can be studied, as though cultured in a dish. When studied, humans, microbes, plants, and animals can all be said to participate in some form of cultural exchange, from cell signaling and aerosolized hormones to mating displays and language. What separates the human animal from nature is that human culture has become a replacement for the natural strategies of survival, making culture seem much more important than it actually is. Though there is one culture, above all others, that has become absolutely critical to the future of human survival, the culture of This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Justin. We want to wish Blair another big congratulations. She shared a first picture of the little new bambino on the internet this week. It's very exciting. Wow. Blair's mama. She's been a mama for like a week now. It's like, this is amazing. Oh my goodness. Well, we don't know how soon we'll see her again on this program. that's a conversation for another day. But what this show is going to discuss is science, because that's what you have come to expect from us. All the science that we feel fit to bring to the show. So, what are we going to bring tonight to This Week in Science? We have a great show full of, I've got a moon landing, light-powered magnets, Martian colonists, fly medicine, bird news, a slippery toilet, and more.
Wow.
What do you have?
That sounds jam-packed.
I know.
Toilet.
Light 90.
There is, what do I have? I have thinking conscious AI, music for cells, population overshoot, and the end of humanity.
Those two things, population overshoot, end of humanity, they kind of seem like they...
Completely different stories.
Doom!
Although which could be totally related.
Doom!
Doom.
Doom. Doom. Well, not too much doom today. Let's try and have some optimism. And
that section of the show will be heavily doom influenced. Just as a warning, it'll come at the end of the show because
it'll be like a rave.
The end. But be brave, be bold, be willing to hear it, or turn off the show. Right?
No. Okay, if you are not turning off the show and you've never heard us before and you're just finding us and you're going, what is going on here? I need to subscribe. Then you need to head over to whatever podcast platform or wherever you are and hit the subscribe button. But additionally, we are pretty much on every podcast platform. Basically, YouTube, Twitch, Facebook. We live stream every Wednesday, 8 p.m. Pacific time-ish. And if you need to find out about stories in the show, we have links and other information at our website, TWIS.org. Yeah. You ready to go?
Let's do it.
Mash those like buttons, because now it's time for the science.
You've been watching too many influencers.
I don't watch influencers.
You must be. This is like
my child watches influencers, and so I hear it in the background.
Just gently click on the icon that will recommend the show to others. You don't need to mash or smash.
I mean, that's for potatoes and grapes, right? Yeah. Yeah. Big news this week. Everyone in the space industry, especially people in India, are very excited about the successful landing of India's Chandrayaan. Oh, wait, I'm going to make the name. I got to get the name. I got to get it right. The Chandrayaan 3 on the southern pole of the moon. They released their lander, which is going to rove the southern pole of the moon. The big research question is the southern pole of the moon full of frozen water that we could possibly use for people? It's a big question. And this is a very exciting moment, as in 2019 they had a failed attempt to land on the moon, but now they have released the rover. They're going to be running experiments, and this is like just a couple of days after Russia's Luna 25, which was headed kind of to the same space, crashed. Didn't work out so well for them on that. The exciting thing, I think, also is that India was able to, and I don't know how the math specifically works out on this, but they are reporting that this Chandrayaan 3 mission cost $75 million. That they were able to successfully do this for $75 million. I really would love to see the comparative math and what they're counting in the accounting for that, but what's exciting is that we are now at the southern pole of the moon. We are able to investigate these research questions, and it also is really bringing India into the lunar environment. So it's the fourth country to successfully land on the moon, and it is really going to set the pace for the space community in the future. So there's going to be more money headed toward India. India's space agency is also looking at partnering with Japan on some future missions. Japan also has a mission that's headed to the moon fairly soon. But overall, this is a very exciting program, landing, mission. Data should be arriving fairly soon from this very exciting history-making event.
Yeah. Well, maybe.
Maybe.
I mean, it's the peril of putting something on a different body out in space. The Russians just sent something to the moon, and it landed, but it landed at a speed unconducive to the health of the lander. So this one is
unconducive. That's a very egalitarian way to look at it. Okay, yes.
This one seems to have landed successfully. Now we have to see if it can also send the data.
Yeah, so hopefully the data will come and we will see that we will have a lot of information about water, where it's located, what this lander, not just the lander, the Chandrayaan lander, but the actual rover that is going to be roving, will be able to find out for us. The moon is a jumping off point, so this is very exciting for humanity in general. Moving past space, I want to talk about magnets. Do you want to talk about magnets? Magnets.
Sure. Yeah, tell me how they work. I'm still confused.
What about these magnets? Oh my gosh, yes. Engineers know a lot more than I do because there's this, spin related to electrons, and there's up or down, and the polarity of things. You can align the polarity so that there's what we call a north and a south. It's not necessarily north and south, but it is in relation to the electrical and the physical properties of the body. And anyway, this new research just published this week in the journal Nature. Researchers from the City College of New York have given some magnets a boost. Yeah, which is it's kind of cool. So they took a bunch of magnets and they layered them one on top of the other. So you've got magnets that are going one direction and magnets that are going the other direction underneath them, and then the polarity is the opposite way underneath that, and the polarity is the opposite way underneath that. So there's these layers of magnets, and that's how the magnets themselves stick together and hold together. But what they're reporting in their work is that these magnets that they used have intrinsic properties that actually have interactions with light particles, and they have quasi-particles. They were able to bind these excited particles, these quasi-particles, and trap light within the magnet. The light bounces back and forth within the layered magnets and enhances all of the interactions. And they were able to determine that it enhanced the normal magnetic response. So they said ordinarily light does not respond so strongly to magnetism. This is why technological applications based on magneto-optic effects often require implementation of sensitive optical detection schemes. But with this, what they have created, it's an enhancement that isn't necessarily that sensitive. And so technological applications may develop in the future to create magnetic lasers, optically controlled magnetic memory might change. There's some very interesting applications that could come out of this. But yeah. Magnets.
Magnetic laser sounds like the sort of thing a second or third grader would make it up. It's like, yeah, well, I have a magnetic laser. So
magnetic laser. Wow. But they could potentially in the future. I mean, this is still in the lab. It was just published in Nature, but it's very exciting that they were able to structure the magnetic material in such a way that it was able to enhance these interactions all the way around, so that the light, the magnets all work together in an enhancing kind of way, which is...
Don't know what I'm having trouble with the word enhance.
It makes the magnet stronger.
Makes the magnet stronger. Okay.
Yeah. So you have a normal, like, whatever Tesla magnet, whatever the normal measurement of the magnetic moment is. And then because of the optics involved in the layering and how they've trapped the light, it is strengthening the magnet itself.
See, the only thing that I'm puzzling over here is, like, how much? Because my understanding is you can actually charge and discharge magnets electrically, so that they can even become, you can make them stronger by applying charge, or right, or so. Are they stronger if they're stronger than, one electron or whatever they're throwing into the system? But it's light, just light, not electricity.
Yeah, not electricity, just photons.
Just light. Yeah.
Photons, lights. And apparently it's supported by van der Waals interactions, for those of you who are interested in the chemical, physical interactions that are happening there. But with the magnets, the electronics, the light that's involved, this could lead to tunable systems that would be stronger than normal because of the way that it all works together in synchrony. So that could lead to new technology. Yeah. I mean, I don't know the details, and I'm sure based on the materials you use and the type of layering and the particular phasing that trying to put everything together into similar phases, that's going to impact the strength of the signal, or the strength of the enhancement of the magnetic strength.
I think it sounds like a completely boring technological advance, which will probably be like the key underpinning to a time traveling machine one day.
Right.
It just doesn't seem in the moment. It's just like, why would we even bother with that? And then it turns out, oh wait,
we need it later.
Send signals now back in time. Wait, how? It's going to be later. This is just an iterative step. Okay.
This is part of it. It'll happen eventually. That's right. Okay, so later, AI is going to be conscious, right?
Agreed? Well, apparently it could be now.
What?
Yeah.
No.
So.
No. What?
Yeah.
No.
Yeah. It could be now. We could design
the estimate said at least like 2050, 2060.
No, it could be tomorrow. The problem is why, more than, and how you define it. So in a 120-page discussion paper
that you read in its entirety.
Look, a 120-page paper is never necessary, and I can't even imagine a scenario in which an academic paper would take 120 pages. Utterly ridiculous. But here's why. Okay, so it's a group of 19 computer scientists, neuroscientists, and philosophers. Okay. They came up with a lengthy checklist of attributes that together could suggest but not prove AI is conscious. 120 pages is why philosophers, by the way, are rarely invited to contribute to other scientific papers, or be invited to dinner parties, or engaged in small talk. Because posted as a preprint this week, 120 pages is going to stay a preprint. There's no editor. There's no editor who's going to look at that and go, yeah, I want that job. Nobody.
Part of it. It's part of the process, Justin.
Okay. Anyway, the researchers draw on theories of human consciousness to propose 14 criteria and then apply them to existing AI architectures. None is likely to be conscious, they conclude, of the existing AI architectures. But the work offers a framework for evaluating increasingly human-like AIs, according to co-author Robert Long of the San Francisco-based nonprofit Center for AI Safety, which is a thing that probably didn't exist very long ago.
But I'm glad it exists now.
Yeah, one of the first tasks was to define consciousness. What are we even talking about? So I imagine 110 pages later, the philosophers handed over the introduction. And the core descriptors of consciousness states were compared to the AI underlying architecture. So to be included, a theory of consciousness had to be based on neuroscience and supported by empirical evidence, such as data from brain scans of humans. I don't know why we're necessarily the benchmark of consciousness, but I guess we're making up the words, so we get to be the benchmark. Data from brain scans during tests that manipulate consciousness using perceptual tricks. It had to allow for the possibility that consciousness can arise regardless of whether computations are performed biologically or on silicon chips. 6 theories of mind were settled on, along with the 14 indicators derived from them. One, recurrent processing theory. This theory proposes that passing information through feedback loops is a key aspect of consciousness. It suggests that feedback mechanisms in the brain are essential for conscious awareness. They also had global neuronal workspace theory. According to this theory, consciousness arises when independent streams of information are collected and converge in a central workspace in the brain, somewhat like a computer clipboard, I guess. It emphasizes the integration.
Right. Yeah, the working
like a
memory.
post-it board, right? Like a cork board. You put all the things you need to remember in one place. Oh, my cork board's conscious. Anyway, it's an integrating information from different sources considered a fundamental aspect of consciousness. Higher order theories. These theories posit that consciousness involves a process of representing and annotating basic inputs received from the senses. They suggest there's higher level of cognitive processing involved in a conscious experience with inputs that are separate from just thinking about something. Mechanisms for controlling attention. Oh, gosh, some of us might not be as conscious as we think if this is part of this. Some theories emphasize the role of attention in consciousness. They suggest that mechanisms for controlling and directing attention are integral to conscious awareness. And some part of it is need for a body that can get feedback from the outside world. This theory suggests that having a physical body that interacts with and receives feedback from the external environment is important for consciousness, which is a very typical bias of meat space thinking.
Meat space, human-centric thinking.
You would need a body. Yep. Agency and embodiment is another. The theory focuses on the sense of agency and embodiment. It suggests that that a conscious entity should exhibit a sense of self and be aware of its actions within a physical or simulated environment. So they took these and had some criteria based on those, and they applied them to existing AI, which I am going to point out, as I always do, is in its infancy. So this isn't where AI can go. This is just little teeny baby AI. See how it checks it off.
Baby AI that has all of the data of the internet. There you go.
Well, if you applied these to a newborn baby, a lot of it would be tough. I don't know how much attention or central workspace is going on. The body is just learning how senses work, it seems, at times.
But that's that's one of the big points of consciousness is that it's not considered that newborns are conscious. That consciousness,
is that right? That's ridiculous.
Seriously. Philosophy, neuroscience, both work together in this hypothesis that consciousness actually doesn't come about until the brain is formed enough for memories to be formed, for physical awareness to be possible, and for like a lot of these theories that you're outlining right now to come into being. So it's thought that kids between until they're like 2 to 3 years old are really not conscious.
That's utterly ridiculous. I'll just tell you right now. Those people don't have kids.
consciousness as a
Yeah.
scientific
I
definition is going to
I've
be.
had
I don't. Yeah.
I've had
Anyway, this is
6 months-olds
a
do
debate.
jokes, do engage in humor. Like that to me is that's it. I got it. So anyway, one variant of the type of GPT language models came close to exhibiting a global workspace. There was Google's Palm E, which I don't know what that is exactly, but it receives inputs apparently from various robotic sensors. Had criteria of agency and embodiment. DeepMind's transformer-based adaptive agent was trained to control an avatar in 3D space. Qualified for agency embodiment, even though it lacked physical sensors, because it has very good spatial awareness in its virtual environment. And none of the AI checked a majority of boxes. So none were considered strong enough candidates for consciousness. Although it was pointed out that they do point out in the paper that it would actually be kind of trivial to design some of these features into the existing AI so that they could check more boxes. But there's not a clear need for it for completing the tasks that the AI was designed for. But actually sort of taking, we can give this language model some physical inputs and have it control a robot and figure out how to move around. Like that wouldn't be that difficult to add that to the language model. It's just that why would be
why do we want to do that?
Like at this point.
Yeah.
But it sounds like, the definitions from philosophers that turned this into a 120-page paper, they just might be wrong. If my newborn children can engage in humor and jokes and trickery, then they may be missing a large piece of the puzzle. They may need to do a 240-page introduction to consciousness.
So the big take-home message from this 120-page paper is that these large language models, they're not there yet. Nothing checks the boxes. We don't have to worry about it. Like this.
Nothing checks the boxes, but to get one that checks the boxes wouldn't be that hard if this is now your goal.
Right. To check the boxes.
If it's your goal to check all the boxes, you could design something likely from what we have existing that could check most of them.
But then again, that is simply checking boxes, and it's not explaining what consciousness is, why it is, how it comes to pass, what it all. I mean,
and that's because that required philosophers. And as soon as we realized all of our definitions in this approach are coming from philosophers, we can just skip past it and interact with a conscious AI with memory, agency, reasoning, and maybe even mood.
Oh no.
Moody robots.
No, I'm not interested. No moody robots. I thought robots were supposed to be predictable. The future is unpredictable. Oh, goodness. Jumping forward from consciousness and artificial intelligence, I want to remind everyone there was a study I talked about last week involving black soldier flies that were their exoskeletons were being ground down to form chitin. The chitin was being taken out of the exoskeletons to potentially form molecules that could be used as plastic polymers, and very interesting. And I was like, wow, what is up with the black soldier fly? There's another study this week out of the Hebrew University of Jerusalem that apparently they're using the larva of the black soldier fly to solve some medical issues. So the larvae of the black soldier fly have metabolites that modulate what are called toll-like receptors and the signaling pathways that they regulate. And there's a possibility that these little baby black soldier flies and the oil that comes from these larvae, that it could help with things like ulcerative colitis. So the oils from these black soldier flies are very high in what's called BSFL oil, or black soldier fly larva oil. Who knew they'd be high in that? And that's high in medium chain fatty acids. And so those medium chain fatty acids are a great source of relief for things like ulcerative colitis. The study is published in the International Journal of Molecular Sciences. And the study suggests that this oil could influence cellular energy utilization, influence these metabolic pathways, and then also facilitate fats and energy and how they're utilized within the body. And so when I was wondering, like, why are they growing black soldier flies? Apparently, there are a number of different reasons that these black soldier flies are in demand these days, and a potential source for helping humanity into our future. Mm-hmm. Researchers suggest that a diet enriched with BSFL, black soldier fly liquid oil, at 20% is really promising for helping out a bunch of these issues.
That's going to be great news for black soldier fly farmers everywhere.
Everywhere. One of the aspects of this that's interesting is that it could, that the pathways that it impacts do reduce inflammation. So if there's, ulcerative colitis is an inflammatory disorder, and so this could go the opposite direction. Who knew it would come from flies? But Justin, what is this story about music and cells and what's happening?
It's a story about diabetes.
No, what? That is it?
Yeah, it's a story about how... diabetes, if you're not familiar, is a condition in which the body produces too little or no insulin. It depends on an external supply of injections or pumps, that sort of thing. This is researchers from the Department of Biosystem Science and Engineering at ETH Zurich. They found an interesting solution to allow people to administer insulin without an injection or pump.
Wait, what?
And this is...
That would be amazing.
So there's a number of research projects that are currently underway that enclose, in this case, they're enclosing insulin-producing designer cells in capsules that can then be implanted into the body. There's other ones that are similar in terms of the idea of you have a cell implanted into the body that can generate mRNA that can produce something in the body. And then you just need a way of stimulating that cell to kind of turn it on or make it active. So there have been all sorts of triggers for these implanted cells. They've used light, temperature, electric fields. There's one that was using a sort of acupuncture needle to then deliver an electric charge to stimulate. The current research took a different route. They decided they would use their trigger to release the designer cell's insulin would be music.
What?
Yeah.
Let me sing at your designer cells. No.
Yeah, so to make the insulin-producing cells receptive to sound, the researchers used a protein from the bacterium Ecology. This protein responds to mechanical stimuli, and it's very common in human animals and bacteria. The protein is located, was positioned in the membrane of the bacterium, and it regulates the influx of calcium ions into the cell interior. They incorporated the blueprint of this bacterial ion channel into human insulin-producing cells that let the cells create the ion channel themselves and embed it in their membrane. And these cells open in response to sound, allowing the positively charged calcium ions to flow into the cell. That leads to a charge reversal in the cell membrane, which causes the tiny insulin-filled vesicles inside the cell to fuse with the cell membrane, and then they are released to the outside.
Insulin release.
So they played around with what frequencies and how loud it needed to be. They found that volumes around 60 decibels and bass frequencies of 50 hertz were the most effective in triggering the ion channels. In the study,
I'm seeing a problem here, though. I mean, 60 decibels is not outside the range of normal activity. Bass, if you're out on a street and there's a jackhammer or, buildings, you don't want these to be stimulated all the time. So what's happening? This is do they have a difference here?
So yes, in the system they found that the researchers that the implanted insulin producing cells were in their bellies, and they were only able to be activated when the bellies were directly on a loudspeaker. So they kind of had to hold the mouse model up to the speaker by its belly for it to work. There was no effect if they were allowed to freely mouse disco about. There was no ambient noise that was triggering this. This had to be the music that was the speaker had to be right up. They found the most effective song from their repertoire in releasing the insulin was the Queen song "We Will Rock You," and apparently the Avengers soundtrack did pretty good as well.
Lots of bass, probably. It's
bass, and then it needs to have a bit of a quiet spell, and then bass. It's a somewhat specific pattern that was most effective. But "We Will Rock You" by Queen was the most effective song in releasing. And so the idea is you could have these cells injected someplace on the body, and you could take your phone and crank the volume up. I don't know if a phone gets to 60 decibels. It sounds like a lot. I don't know if
it's within normal. 80 something is where you start to get high decibel range. Yeah.
So you can crank up maybe a phone, maybe you need a special speaker. Put it over wherever that spot is where you've got those cells, and it can do a insulin release without an injection, without pumps and surgeries and stuff. Well, I guess there's a surgery to embed the cells, but that's about it.
Or an injection, or you'd have to take these genetically modified cells and insert them into a person in some way. Right now it's just mice. And I do love the idea that scientists are just, doing work for mouse disco time. But
and this is one example of this insulin release. The concept of this is creating cells that can produce basically a lot of different a lot of drugs are designed to turn on or turn off activity.
Yeah.
To encourage or discourage mRNA from moving around and creating proteins of this, that, and the other to do downstream effects. If you can create cells that can just directly make a specific mRNA and feed it to the body, and then have an external trigger that you can be in charge of when it's doing it or when it's not doing it, then you really start to get to a point where you're replacing external medicine with internal machinery that's missing or malformed in the body.
Yeah, and I love that they're using this membrane deformation. I mean, we already have pressure-sensitive membrane ion channels within cells of the body. The mechanoreception is not an unfamiliar thing for our body and our cells to deal with. So that in itself is a very interesting, just very basic biological solution to this. But then to figure out, I think the issue is the specificity, so that you don't have accidental release. so that it is at a certain time, at a certain place when you're ready for it.
Yes.
I mean, I love the idea of, oh, I'm going to eat dinner now, or I just ate dinner, and you hold up your We Will Rock You recording to, your neck, your stomach, or, wherever the cells happen to be. There's an interesting aspect to that, but I think there is definite care that needs to take place in how this is implemented, but it has really interesting potential.
That's a very important point you bring up. Don't try this at home.
No. I mean, I don't know. People are DIY biologists all over the place, so who knows? Maybe somebody is going to try it.
In that case,
I'm not in charge of that.
Do what you do.
Nope, not in charge of that. Nope. Wait for a doctor. Wait for it to be released for everyone. We know very well that you do not want to go to Mars, right?
Me?
You.
No, I like this planet's actually perfect for me. All the other humans are more than welcome to find their own planet somewhere else if they like. But I like this one.
You like this one. Many times on the show, you've said, nope. No, I'm not going to Mars. It's okay. Researchers just published a preprint in the archive preprint server. They're from George Mason University, and they did computer simulations to try and figure out the minimum number of people required to successfully start a Mars colony. And they simulated the types of personalities and various factors within those personalities related to resilience to stress, social skills, degree of neuroticism. There were a number of these characteristics that they've put together. We know that
my guess is you need really boring people. I mean, really well-adjusted, non-neurotic people.
So they ran 5 simulations that were modeling 28 Earth years of colony life. So, of course, this is not something that we could have done here on Earth. On Earth, we have a number of Mars simulations that are ongoing in various ways on the island Hawaii. And I hope people in Maui and Lahaina and those places are doing well. And if we can support them, that would be amazing. And additionally, there's Antarctic research and other research in deserts, places like Utah, others that are simulating these possibilities of colonizing Mars. They determined the minimum number of people required to keep things going. 22.
Oh, that's small.
22 people. They had to have agreeable personalities. Those agreeable personalities were more likely to survive and thrive and persist. And people with a lot of neuroticism, they died in the simulations. So they're computer simulations.
Yeah, they died out of boredom. Is what they don't tell you. They were just like, oh, I've got to be for how long? I
find this whole simulation very fascinating because it's not just psychological, but also behavior and environmental. And the way that they looked at all this, I just think it's really just incredibly fascinating that they determined that neuroticism is not a really good trait to have for a colonist on a planet that might kill you.
This should also then, what's kind of funny is like you would think, okay, any long-term voyage or any time when you have to work closely with others and be in a confined environment for a long time, and this is a ridiculous place that my brain goes, but then I think, I bet you pirates must have been really, really good mannered, really easy to work with. You couldn't have a bunch of neurotic pirates. They're at sea for more than 28 days. Yeah. My goodness.
Yep. And your comment about boredom also is important. The way they define stuff in their paper, neurotics, individuals with a high degree of competitiveness, highly aggressive interpersonal characteristics, and challenged ability to adapt to boredom or a change in routine.
Yeah.
So it's the kind of thing where if there's a crisis, that's going to lead to a change in routine. They're not going to adapt very quickly. They're not good at boredom either. So they might just walk off into the insubstantial Martian atmosphere just because that's better than being bored. Or they're going to not get along with everybody, and their aggressiveness is going to limit their ability to maintain
I'm guessing
sociality.
the neurotics also are just like, it's just occurring to them. Like that they're on Mars. Like they didn't think it through or something. They're like,
How did I
do
get
you realize
here?
how hard it is to find an Earth-like planet in this galaxy? Do you realize what we just left? Let's talk about it too much. And then they're gonna write a 120-page philosophy paper about all of the reasons that they should have stayed home.
Yeah, this preprint is not 120 pages, but it kind of makes sense, and it's let's try and put agreeable people who can work together on a place that's going to try to kill them all the time. Might make sense, possibly. Yeah. I don't know. You might add a few more than 22 just in case.
Well, and the thing is that this is only for what, a 28-day
no, year. 28,
28 year. I'm sorry. Yeah.
Yeah.
28 years. Ooh.
Yeah.
Yeah. 28-year mission. And what is it to get to the nearest star? It's like 100 generations or more. That would have to be. Like you would have to have an airlock and a policy.
I mean, this is just for Mars. We're not talking about generation ships. We're talking about Mars.
No. But I'm talking about the nearest star. If we ever start thinking like, whoa, we'll go find another Earth-like planet. You have generation after generation after generation where they have to. You get a personality test when you're 13, and they're like, "Oh no, okay, we have coached you. You cannot give any of these neurotic answers, or they're going to throw you out the airlock because the population's growing beyond what the ship can handle."
What if I'm neurotic? What if? Oh my God, I can't handle boredom. What if
If you're asking, what if I'm neurotic, you're neurotic. Because that's the only one who's like, oh, I'm worried about whether or not I'm neurotic. Why? I don't know. I must be neurotic. That's the only explanation. They're sending me to the airlock, aren't they?
Right now, we're sending you to tell your friends about TWIS. Thank you for joining us for another episode of This Week in Science. We're so glad that you are here to join us once again. We have a few more stories to get through for the rest of the show, so don't miss it. And if you don't want to miss any show, and if you want to be a part of keeping this show going week after week, head over to twis.org, click on our Patreon link, and you can choose your level of support, $10 a month and more, and we'll thank you by name at the end of the show. You can be a financial supporter / producer of This Week in Science. We really cannot do what we do without you. Thank you for your support. All right, let's come on back right now with some Blair. No, Blair's got a baby. So it's Kiki's Bird Corner.
With Kiki.
Yeah. Hey, Justin, what makes you a great dad?
Patience.
Would you consider yourself a super dad?
Yeah, sometimes.
Sometimes you're a super dad. Well, in house sparrows, recently published in Frontiers in Ecology and Evolution, these urbanized house sparrows, the males, oh no, sorry, not house sparrows. Nope, bloop, 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 bloop. Not the houses. The song sparrows. Male song sparrows in the city are like super dads compared to their rural counterparts.
Mm-hmm.
Researchers...
Why so?
Yeah, why so? Researchers who were working out of North Dakota State University and also Virginia Tech, they expected that city males were going to be super busy defending their territory, and so they wouldn't have any time to be good dads.
Wait a second. North Dakota and Virginia. Where did they find a city? What are they talking? How do they define city in North Dakota? I'm not. Come on, nothing. I'm just saying, like, when you say city, I expect you mean a city.
Urban environment. An urban environment, yes. Well, so they looked at urban male song sparrows and rural male song sparrows, and they looked at the number of times that they visited the nests. So after the eggs hatched, how many times did the males go help out at home and feed the babies and take care of things? And other questions were, what else were these males doing? Were they out singing, defending territory, doing other things? But what they determined is that these city males are doing it all. They're defending their territory, they're hanging out with their mate, and they're helping out at the nest, feeding the babies, taking care of them. The offspring are like better, and the rural males are just doing their thing normally. But because of the urban, the hypothesis now is that because of the urban environment, that these males are super hyper stimulated for success. And so urban song sparrow dads are super dads compared to rural dads. Sorry to say it.
Seems like birds in general adapt pretty well to human civilization.
Yes and no. And it depends on the species. And so this is song sparrows. This isn't, like I said, house sparrows, we also know, are in cities and urban environments. So maybe there's something there as well. We don't know. But it depends on what the species are able to adapt to, right? How generalized can they become? Are they good at adaptation, or are they like neurotics who don't like change in their routine? It has to be this way.
There's such a plethora of crows and seagulls in this neighborhood, and they're hanging out on the tops of the buildings, and they're hanging out in the parks, and they're kind of everywhere. If it was like, it would be surprising to me if it was, some badgers. Some animals I think tend to avoid humans at least.
Some species definitely avoid humans, and so this would not have the same turnout or results at all. So, some species, the generalists, the ones that are good at adaptation, they can thrive within human environments, and in these situations, be super dads. Super. Moving on from song sparrows, we got to talk about hummingbirds. Hummingbirds are wonderful. People love hummingbirds. Everybody wants to have hummingbirds come to their backyards because they're like bzz, bzz, and they fly up and then they hover at that red or yellow or orange flowered tree or the purple, whatever, the color, and they go get the flowers, they get the pollen. They're pollinators. This is amazing. They do the hover feeding. It's so great. Except sometimes that's not what they do. And so researchers published...
say something bad about hummingbirds?
Nope, just that there are some sneaky-footed hummingbirds out there.
Sneaky?
Footed. So a researcher just published 50 years worth of research into hummingbirds, phylogeny, their beak length, their foot length, the foot size, their body size, all sorts of. Just published in the American Naturalist, biology professor emeritus Robert Caldwell and his colleagues had been looking at this for a very long time, started back in the 1970s, and found some magnificent hummingbirds. And that's actually a species of hummingbird in Costa Rica, at a site 10,000 feet above sea level. The largest, the magnificent hummingbird, of the 4 species that they were looking at that elevation had smaller feet than the lighter 6-gram fiery-throated hummingbird, who had a shorter bill. So this little bird had big feet and a short bill, and the big bird had a long beak and short feet. And so he was like, what is happening there? Started putting data together, started putting phylogenies together, and he said he actually had enough data for a paper back in 1986, but he opted to collect more data. So now, 50 years later, the paper has come out because in 2014, a phylogeny of hummingbirds was published by some researchers in Berkeley, and so that allowed them to take a whole bunch of their data, connected with the phylogeny, and they have measurements from 1,172 museum specimens, 386 field captures, representing 220 species of hummingbirds. They pulled all the behavioral data that they could find together. They went through every book, photograph of everything that they could find. And excluding body size, phylogenetic relation, whatever. Big-footed hummingbirds tend to have shorter beaks, and they stab flowers and suck the nectar out through the bottom, and so they steal the nectar in a sneaky way, and they're sneaky big-footed hummingbirds. This isn't necessarily a problem. It's just one particular adaptation that is kind of interesting because we look at hummingbirds, we go, oh, they hover, and they're going to go in, their beaks are adapted to go into the flower, and those birds are pollinators. The question is, are these stabby, big-footed hummingbirds pollinators also? Not so much, because they're not getting into the flower in the same way.
They've got the rounder. They're sneaky. They're avoiding the pollen.
Yeah, and so these researchers, they're kind of like they're kind of nectar thieves, and it's a downside for the flower because pollination is not occurring, and unless the flower has a way to seal that injury and produce more pollen, it's going to lead to that flower being less desirable by other hummingbirds. But it's really kind of an interesting relationship. Foot size and beak length in hummingbirds are correlated to whether or not you are a nectar thief, or whether or not the hummingbird is a nectar thief.
Interesting.
Who knew? Who knew sneaky hummingbirds, and why were their feet involved in the first place? And all right, you ready for your 2 stories?
Okay.
This
is the part where I recommend everybody turn off the show.
No.
You're not...
We're okay with doom.
Oh, okay.
Doom. We can handle this. It's okay. I have good stuff afterwards. Come on, don't turn it off. Keep going.
Okay, so all life on Earth has a survival strategy, a way of living that allows current populations to thrive and ensures that there are future generations of that life form. And they find usually a niche in a biome, adapt to a changing environment, and tend to find a balance that can last for tens of thousands of many more years before significant change is required and new strategies can be adopted, usually gradually over time. It doesn't always work. Sometimes animals go extinct. There are more extinct species from planet Earth than there are species living now. It's just the story of life on the planet. Current modern human strategies evolved to reproduce exponentially, expand geographically, and consume any available resource. It's been highly successful. We've done amazing in terms of putting humans everywhere that they can be. As long as there's more land and more resources, we will be able to continue to ever expand our population with this strategy.
Yay, where's the more land? And where's the more
Well, yeah,
resources?
there might be a
Yay!
limit.
What?
And what happens when you hit a limit is that this is the subject of the paper by a University of British Columbia researcher, William E. Rees, entitled The Human Ecology of Overshoot, Why Major Population Correction is Inevitable. It's currently published in the journal World. Overshoot is actually, it's from a book, maybe another essay previously, refers to human population consuming even the replenishable, self-reproducing resources faster than the ecosystem can regenerate them, and in producing waste greater than an ecosphere can assimilate. In short, humanity has, according to this study, already exceeded the long-term human carrying capacity of the planet Earth. We're totally out of control. But we aren't actually subverting the laws of nature, according to the paper. We are simply following them to a natural conclusion. Like all species, humans are predisposed to grow, reproduce, and expand into the suitable, accessible habitats. The difference with us is that almost any habitat is suitable. This is true of some other life forms. Ants, for example, will continue to expand into suitable habitats. The difference between us and ants, and I don't know if anybody's noticed this, we're bigger, which is perceptually sort of as though ants lived on a much bigger planet than we do. Our planet comparatively is extremely small. And I have to tap out for a minute, and I will continue this story on the other side.
And I just lost Justin. What happened there? I was doing a brief comeback, and then Justin disappeared for a moment. He's got to move his computering. But here we have, from his story, the increase in population versus the years, along with some instances of the increase in things like fossil fuel use. And he'll be right back. I know he said he had to tap out. He'll be right back. But additionally, the GDP versus oil consumption increasing. This particular study is fascinating because it is kind of something that people have been talking about for a very long time. The carrying capacity of the planet is something that I was very familiar with as an ecology undergraduate biology student. And in the process of learning about the carrying capacity of environments, it became very apparent that sustainability is not something that is looked upon or at least considered really when it comes to capitalism and the way that we run our public commons, right? Our public goods and resources that we all work together. So a study like this that is bringing up overshoot and population correction, I do think it is going to happen. The question is when it's going to happen. Last year, 2 years ago, there were some estimates of human population that maybe will be affected by things like family planning, education for women, and other factors related to society and how culture works together, whether or not we're able to look at things from a more sustainable perspective. But according to those studies from a group out of, there's UN that makes estimates, and there's also another group out of University of Washington that does these estimates. They had estimated that we could reach as many as 10 billion people by 2080, and then that might reduce to about 8 billion or 9 billion people by the end of the century if things went according to family planning and other factors that could be involved in choices and the education that women have. So we have a lot of aspects, a lot of parameters coming into this doom and gloom situation of the future and how the world is actually going to work. But I mean, yeah, we are using things, we're not replenishing them. And unless we can start bringing things from asteroids, hey, Phobos, what? Maybe, maybe we are stuck where we are.
What are you talking about?
The story that you were talking about. I just kept.
Oh, no, it gets worse. I didn't even get to the end of it.
No, you didn't get to the end of it?
No, that was just the beginning of it. So,
Okay.
yeah. Okay, so here's the good news at the end of the paper. I'll just skip. It says that it is unlikely that humans will go extinct. Wealthy, technologically advanced nations potentially will have more resilient and be insulated, at least temporarily, for the worst of the consequences of things like global warming and all the war and climate chaos, food and other resource shortages, civil disorder, that sort of thing. Just for temporarily. What kind of gets left out of this is that once we don't have the abundance of cheap energy and resources, we also are going to have a shortage then of cheap human labor to gather all that stuff.
It's already starting.
Maybe that the best case future, according to the paper, will be powered by renewable energy in the form of human muscle, draft horses, mules, and oxen.
What?
Yeah, he's apparently predicting in the worst case scenario, even a return to the Stone Age lifestyle.
No, thank you.
Because even with renewable energies, these are globally sourced with components that are, the batteries themselves aren't really easy to make in your backyard. The one group though, this is the silver lining for humanity. The one group that should be doing okay is the remaining pockets of indigenous peoples who are sort of already trained to live in that world, or already adapted to a world without heavy reliance on industrialization.
And technology. Yeah. Yep.
Yeah. So, hope for humanity. Especially those, can you imagine those rural Amazonian tribes, or some of the uncontacted people, when they noticed the metal birds have stopped passing over, or out on the island, where's the uncontacted tribe on the island south of India, I think it is, where they just notice there's no more boats or planes going over, and eventually come out to explore the world. Why, they're going to find all this technology to back engineer if they should so choose. Yep. Because all of civilization will have collapsed elsewhere. And then my last story.
Thanks. Okay. Woo! So optimistic. Okay. Yeah, last story. Here we go.
It's not that it's not optimistic. It's the natural conclusion of using all of the resources and continuing to add to the population. It's just how it works eventually.
Yeah. Okay.
So there's but that's the silver lining for humanity, is that there are people on the planet who should be fine with this. And his last story is, the future of all humanity is looking bleak.
Wait. Why?
There has been hope that when global warming, pandemic, or eventually bring about the population correction in the previous story, that some humans would survive. Remote living humans, the indigenous folks, the uncontacted tribes. Unfortunately, research from Bolivia has found that rural indigenous peoples of the Amazon suffered disproportionately from the COVID-19 pandemic. The idea was being isolated would have protected them. Right. But the problem...
They wouldn't get it. They wouldn't be exposed, right?
Yeah.
Yeah.
The problem, I think, was The information was slower to travel to them, that there was a danger. The methods of avoiding spread weren't as available. You could, try to order a mask from Amazon delivered to the Amazon, and you'll find it very difficult. These are also groups that work very closely with one another. The different community villages visit each other. They have communal meals. They have, large numbers of people gathered. They're actually much more social than people are in the Western world in a lot of ways. And so, they did some simulations. There was groups that they were working with during the pandemic that they were helping keep isolated and keep protected. But they have found that another part of it is a lack of access to medical. Like, they don't get, even if they're in a system that should give them access to a county clinic kind of a thing or a rural clinic,
maybe they're too isolated barriers. There's a whole bunch of factors.
And then there's the unconnected tribes. Yeah. So anyway, it turns out that it was some of the outbreaks were actually more severe in very remote places, according to the prediction, could be much more disastrous there than in other places. So we basically there's 10,000 people around on this planet right now who are in uncontacted tribes. Now, even these rural Amazonian indigenous that were part of this study are contacted. They're in communication with the outside world. The uncontacted, the ones that are like, we just don't want anything to do with it, about 10,000 people globally. That's it. That's who survives. That's who survives the global pandemics. That's who survives the everything. It's just that completely uncontacted group.
It's way better than a lot of endangered animals right now, like endangered species that are down into the sub 1,000s, hundreds. Yeah. Like, that's better than a lot of other.
Would be plenty.
Yeah. You could do that.
The only thing is, that's down from 8 billion.
Yeah.
Ish.
Yeah.
Anyway, being super rural in the Amazon did not protect people from COVID because that pandemic went everywhere.
Everywhere. Well, I'm sure part of it was also, trade that was happening and people coming in specifically to help, also bringing it, and then there not being a lot of protections and lots of issues. But it's an interesting perspective to consider because you look at the world and think, oh, we're really connected, but there are those disconnected places. People are going to be fine. There's going to be that, but.
And disconnected means also that you're not going to get the information as quickly. You're not going to have personal protective implements in this pandemic's case. You might not get the information on how to prevent spread, and vaccinations are going to reach you last.
Yep, they will get to you. They're not going to prioritize those communities. Yeah. Okay, well, let's go from that doom to some good news. Should we do some good news-ish?
Yeah, we could use a good news refresher after all of that.
Yeah. Okay, so researchers, this is similar to an area of research that I have been very interested in for a very long time, related to learning and memory and how people learn and remember. And when I was in grad school, there were researchers who discovered that there was neurogenesis. Neurogenesis is the process of new neurons being born in the brain. And the area of this neurogenesis is the hippocampus, which is an area related to learning and memory. We've seen that over and over again. And so researchers finally were trying to investigate this a bit more. And they're like, okay, we can't look at people. We can't cut apart people brains. So yes, again, we're going to have to look at mice. But these Columbia University researchers just published in the journal Molecular Psychiatry their work looking at hippocampal neuron circuits that are based on cells born when a mouse is an adult. So this neurogenesis process in adult mice. So what do baby cells have to do with memory? Why are they involved? What's going on? Why are they even there? So the researchers decided that, hey, we're going to irradiate the hippocampus of these mice, which basically is going to kill anything that would be dividing and turning into a new neuron. So all the cells that are left would just be adult cells. And they found that when they irradiated the brains of these mice, there were no new neurons being born. That was the first thing. And then they found that there was a progressive decline over about 5 months, which is about a quarter of the mouse's lifespan, in working memory. So this is the mental sticky notes. Okay, got to keep a phone number in my head. Oh, how to remember your name. Okay, so I'm doing this thing right now, but I have to remember this thing while I'm doing it so that I can take care of this other thing. Working memory is the very short-lived memory, but it allows us to function with multiple things going on. Working memory might be pretty important for what we think is good multitasking. But anyway, when they nudged neurons to try and replace the impact of that irradiation, they saw that they were able to fix the problem with the memory. What did they use? They used a drug that releases acetylcholine in the brain. Acetylcholine is a stimulatory neurotransmitter, and it was able to compensate for the loss of neurogenesis, and then also the brain tried to compensate, these mice brains tried to compensate for the lack of neurogenesis by making new connections. Mm-hmm. But they were weird connections. They weren't right.
Yikes.
So it's interesting because researchers for years have been like, yes, new neurons in the brain, they're important for memory, but we haven't really figured out why or how they work. And so now there's a little bit more of a piece of the puzzle for the mechanism, for the neurotransmitters involved, where these little baby neurons being born in the brain, why they're important. And so this could lead to treatments that will impact aging and dementia beneficially. So good news. Maybe, just maybe, you'll be able to age gracefully. If this research moves forward. You don't plan to age gracefully?
No, that's the whole. It takes all the fun out of aging.
Okay.
The excuse.
Beyond your brain, there's also just living longer. Researchers at the university. Yes, researchers at the University of Rochester have taken a longevity gene from naked mole rats and given it to mice. And guess what happened?
No, did they get the mice to live to be 37 years old?
Well, not 37 years old, but longer than they would normally live. So the mice lived longer. They didn't get cancer. They had good memory. This is a gene that reduces the naked mole rat's likelihood of getting cancer. It's a gene responsible for making what's called hyaluronic acid. Hyaluronic acid, we know about it. People are like, let me get the lotions and the skin treatments with the hyaluronic acid. It's going to make my skin youthful. But this genetic shift for mice improved health and led to a 4.4 increase in median lifespan for the mice. So the gene, not necessarily only related to reducing cancer potential in the naked mole rats, but also related to reducing inflammation, maintaining a healthier gut. And who knows, maybe someday you too will enjoy the genes of a naked mole rat to live longer.
What gene was it that they?
So the
I
gene
want to
that,
make sure. I
yes, the gene that they were specifically looking at is responsible for making the high molecular weight hyaluronic acid. And this is not something that mice have in high quantities. Humans have it a little bit, but not in high quantities. And when they removed it from the naked mole rats were more likely to produce tumors. And this gene
more likely
is,
because right now
you
they
didn't have it.
like typically in wild state they don't produce them. They're basically cancer proof.
There's another spider there. The version of this is called the hyaluronan synthase 2 gene, which is making this high molecular weight hyaluronic acid. We all have it, but it just depends on how much it's expressed. We don't express it as much. Mice don't express it as much. Naked mole rats express it a lot.
So what's interesting though is that so we're high performers when it comes to longevity already. There's a handful of species that do really, really good at this.
Yes.
The mole rat is naked mole rat is right up at the top.
Yeah, elephants are long-lived.
Elephants are long-lived. There's a bowhead whale that can be 200 years old.
Yes.
That's like the longest. It even beats the tortoise.
I'd love to know we think of some species as almost immortal, like the mostly like ocean species.
Hydra?
Yeah, like hydra and the sea urchin. Like there's some really, really old sea urchins. I'd love to know if they have this pathway involved as well. But
yeah, but the thing that's in common with a lot of them is that they seem to have genes that are involved in sort of cell recycling, autophagy.
Yes.
Everything that lives a really long time is turning over those cells and recycling them and reworking them for not allowing. Mice are usually only live like a year.
They have a super fast lifespan, so everything's this comparative thing, right? It's like,
and mole rats
can
be like 30, get to 37 years old or something like this. So they
live decades.
The difference is huge.
Yeah. So looking at it, at all of this in mice is just one of the first steps, because obviously there need to be more steps looking to see how this specifically works in longer lived species who don't have as high of a metabolic process, who live much longer, where different forces are beneficial to adaptation.
Yeah. And it's also one of those weird things, like elephants live almost as long as humans, but because of their size, their metabolic rate, like there's some weird thing that they do where it depends on how big you are, whether or not you're aging better than others.
I'm not aging very well right now. There's a spider on my pop filter.
You're aging fine. You have in studio guests.
I do. I have a lot that I keep watching. I have several little teeny tiny in studio guests right now. I need to get my feather duster tomorrow. Okay, last story of the night. We have all been so very happy with the fact that we have indoor plumbing, that we have a place to flush our excrement. That
one of the greatest inventions in the history of civilizations.
Right. And then there's the other invention, which is the cleaning squirty bottle that you use to clean the toilet, that the blue stuff goes down through the toilet to clean it off. And then the scrubby brushy at the end of a wand that you use to clean anything that may have gotten stuck to the toilet bowl.
They just need to make a better toilet bowl.
Well, apparently they have. And I'm not kidding.
You've got my attention now. Hey, there's a
Suddenly.
better toilet. That's what we need.
Published in Advanced Engineering Materials, these researchers have developed a super slippery flush toilet. Huazhong University of Science and Technology in Wuhan, China. They have a long-lived toilet history. But anyway, they have developed a silicon embedded surface for a toilet that is so much better than pretty much every toilet surface out there. So they made their surface, embedded the silicon in it. So we know anti-stick silicon, it's this nice slippery substance. However, they then scrubbed it up and abraded it with sandpaper. Didn't mess anything up. It was still very slippery. They tested the material in a number of different substances to see whether anything stuck to it. Nothing
like a lot
stuck
of
to it.
the stuff that they just showed in this little example just didn't matter. But then they showed honey.
Honey's sticky.
Honey is like the stickiest natural thing on the planet almost. Then the honey didn't stick to it.
Yeah. So then they've made, little tiny model toilets, and they created different stickiness, viscosity type substances. They tried to simulate flushing. They tried to figure out, how everything would work, but they've discovered a really, really slippery toilet surface that could maybe reduce the amount of water that we use every time that we flush, and keep your toilet bowl cleaner without having to use a lot of noxious chemicals.
So everybody needs this immediately.
And you know what they? You want to know what they call it?
I'm taking all of my investment dollars out of the black soldier flies, and I'm buying every bit of this toilet stock.
And they call this toilet invention ARSFT.
Huh?
ARSSFT. ARSFT. Abrasion-resistant super slippery flush toilet.
Maybe it's a translation from a different language and makes more sense somewhere else.
I don't know. That's what they call it. But it's pretty much a non-stick toilet, and it could... I don't know. Could be.
Yeah, but they got the wrong name. I'm taking all the money that I put into it. I'm taking it out.
Sliced
That's
bread. Don't invest in toilet paper. Invest in ARSFT.
Wait, how is it replacing toilet paper? You still need the toilet paper.
Oh, you still need the toilet paper for yourself.
Like,
at least it's not a Greek or Roman sponge thing. Those were not nice. Yeah, and they were shared. That was not sanitary. Oh, history, people. Yeah.
Don't learn it.
It's very entertaining. I mean, if that's a rabbit hole you want to go down, maybe turn your rabbit the other way.
Rabbits, on the other hand, rabbit fur, nothing finer.
Chinchilla. There's spiders. I don't know how spider fur feels. But anyway, have we made it to the end of the show? You've got sun in your eyes.
It's blasting right here through the window. The one window that doesn't have any kind of covering either. So there's nothing I can do about it.
So we've done it. We've made it to the end of the show. I want to thank you all for joining us for another episode of This Week in Science. It's really great that you in the chat are here chatting while we do the show over in Discord. Thank you for being there. I see you. I would love to say specific thank yous, shout outs to Fada. Thank you for all your help with social media and show notes. Identity 4, thank you for recording the show. Gord, Arnlore, others helping to keep our chat rooms nice, wonderful places, positive places to be, not full of doom. Thank you for doing that work. Rachel, thank you for editing the show. I think there might be some moments that deserve your attention this episode. And especially to our TWIS patrons. Thank you so much for all of your support on Patreon. Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badged, Bob Coles, Kent Northcote, Rick Loveman, George Corris, Pierre Velazar, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Begard Chefstad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan, Sarah Forfar, Don Mundis, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paul Ronomich, Kevin Rudin, Noodles Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Clemmy Day, Jay Burton, Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkan, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for all of your support on Patreon. And if any of you are just sitting there going, oh, how can I help? TWIS, what can I do? Head over to twis.org and click on that Patreon link. On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, broadcasting live from our YouTube and Facebook channels and from twis.org/live.
Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found. And if you enjoyed the show, really get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org. And you can also sign up for a newsletter.
It'll come to you someday, and you can contact us about that newsletter directly. Email me, Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just put TWIS somewhere in the subject line so your email doesn't get spam filtered into doom that we all want to ignore anyway. So don't do that.
You can also hit us up on where are we? Are we anywhere still?
We are places.
On the platform previously known as Twitter? Is that what it's being called now?
And Instagram and Twitch and the Universidon. TWIS Science.
We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes due tonight, please let us know.
And we will be back here once again next week with more great science news. We hope you join us.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done...
Court says just call it Twitter.
Just call it Twitter. I don't know what I even do anymore. The fracturing is what we would call it. This is the after show. We're not fractured. We're still here for a moment or so. Justin, you have a child who is elsewhere on the premises. Is there a
Possibly. Still.
Are you responsible for this child at this moment in time?
Well, am I being responsible? No, but I do have to go and send them off.
Has the other parental unit?
Yes, but the other parental unit needs to get ready to go to work, so I need to go and be the other parental unit person.
Yeah, I understand that. I would like everyone to know that maybe for a little while our after shows are not going to be as exciting and long as they might have used to have been, but
the children, they're vampires.
We have some children.
All of the time and energy out of the world.
Well, there's responsiponsibilities, and so it's not all the time and energy. And maybe we'll figure out
totally
other ways to
like,
do it.
I would probably do it again.
Probably. You've done 4 times.
Yeah, maybe.
4 times. But anyway, yes, I know you've moved already. Everyone, thank you for joining us for another show. And is that it? Do we have news? Do we have anything that... No, that's it, right?
I ain't got anything. I gotta go.
You gotta go. Okay, so say the thing. Oh, wait, no. Good morning, Justin.
Yeah. Good morning, Justin. Say goodnight, Kiki.
Good night, Kiki. Good night, everyone. Thank you for joining us for another episode of This Week in Science. We hope we'll be able to do longer after shows at some point in the future. But right now, stay safe, stay healthy, stay curious, and as Justin would love you to do, stay lucky.
Stay lucky above all else. If everything else fails, you'll have that.
Above all else. Good night.